Okay, I was asked to do a video on how to do the law of universal gravitational worksheet. This is the main equation for universal gravitation, where F of g is the weight of an object, how much gravity is pulling on it. It can be calculated by using the universal gravitational constant, g, doesn't change, it's always 6.673 times 10 to the negative 11 Newton meter squared kilogram squared. You'll be using this number the entire time. Multiplied by the first mass, the mass of the first object, multiplied by the mass of the second object, divided by the distance between the centers of the two objects squared. So if you have two planets, it's the distance between the center of the first planet and the center of the second planet. If somebody's standing on the surface of a planet, it's going to be from the center of the planet to the center of the person. This is the distance we're looking for. So I noticed that this did not translate well. So make sure that you have 6.673 times 10 to the negative 11 for this value. This worksheet, you're going to need the masses of the planets and the radiuses of the planets to work the equation. You also have some distances and you have some conversions. All units to plug in to this equation must either be in newtons, meters, or kilograms. If it's in any other units, you're going to have to convert. So, question number 1. How much would a 70 kilogram person weigh on Mercury? So, how much he weighs is this equation right here. F of g is how much gravity is pulling on something. So, it is the weight. You have a person, this is your mass 1. The mass of Mercury is your mass 2. So F of g is going to equal big G, universal gravitational constant, 6.673 times 10 to the negative 11 times the mass of the first object, which is 70, multiplied by the mass of Mercury. If you go up top, it's 3.32 times 10 to the 23rd kilograms, divided by the radius of Mercury squared. 10 to the, I don't have my glasses on, 6 squared. So first time I'm going to plug this in to an iPhone to show you how to put scientific notation in on using a cell phone. So to put the constant in, 6.673. This EE right here is your scientific notation. So hit the big E, and then you're going to put negative 11. Do not use the subtraction sign. You're going to use the plus minus 11. You're done. So it's in. Multiplied by 70, so go times 70 times the mass of Mercury. So 3.32, hit the EE, and I'm going to put to the 23rd. Now I have put in all the numbers for the numerator. I usually just go ahead and hit equal at that point. Now you need to put in the denominator. So you're going to go divided by, because the iPhone sometimes is quirky, I would go ahead and put this part in parentheses. So open the parenthesis, 2.44 EE to the 6, close the parenthesis, and then you're going to square it. Here's your square right here. So you hit square equals. And if incorrectly, you should get 260 newtons. Depending on what calculator you're using, it may show up as 2.6 times 10 to the second newtons. Same thing. This is how we normally write it. This would be scientific notation. Now, to see if you got it correct, the answers are on the back. I give these answers so you will know if you're inputting it correctly, because it's a lot of numbers. Number 2 is worked just like this, but instead of Mercury information, you put in Neptune. Now, I'm going to go ahead and work number 3. It's a little bit different. So on this one, Captain Kirk beams down to a planet and it's the same, number 3. If Pete, mass of 90 kilograms, sorry about that, weighs himself and finds he weighs 30 pounds, how far away from the surface is he? So, here's Earth. Here's Pete. He's up on a mountain somewhere. Okay? So, we're going to find out if we calculate, the distance between planet Earth, the center of Earth, and the center of Pete, that is the R value we're going to find. They want to know how far above the Earth's surface is Pete. Well, we're given on a chart the radius of Earth, and this is the distance. So if we subtract the radius of Earth from this R value, take this away, what we're left with is how far Pete is above the Earth. So that's how we're going to solve the problem. One of the problems they gave us, though, is they gave us Pete's mass. Pete's mass is 90 kilograms. No sweat. The F of G, or how much he weighs, they gave us as 30 pounds. Well, it has to be in kilograms. It cannot be in pounds to plug it in. On the piece of paper up top, right here, it gives us a conversion factor. 1 pound equals 4.545 newtons. Okay? So we're going to multiply this by the 30 to find how many newtons we have. And what you're going to get is 136.35 newtons. So you have F of G, you have the mass of Pete, you have the mass of Earth. It's on the chart. So now we can plug it in. Excuse me. So here we go. Here's our formula. Mass 1, mass 2, distance squared. Okay. We need to solve for R. We need to solve for this total distance so that we can then subtract the radius. So I'm going to rearrange this. R is going to be the square root of G times mass 1 times mass 2 divided by your F of G. Plug in the values. 6.673 times 10 to the negative 11 times Pete's mass, which is 90, times the mass of the Earth, which is 5.98 times 10 to the 24th, divided by our F of G, which we said, when we converted it, is 136.35. So this time I'm going to use a regular calculator. So solve for R. R equals square root, I hit second and I hit the x squared because it gives me the square root. 6.673. To do exponents here, you go second, and you hit the EE here. And negative 11 times 90 times 5.98 second, push that button, to the 24th. Put all these numbers in. Now I'm going to hit divided by 136.35, and R is 1.623 times 10 to the 7th. So this is the radius between, or the distance between the center of Earth and the center of Pete up on his mountain. Now we need to subtract the radius of Earth so that all we have left is this distance. The radius of Earth is 6.38 times 10 to the 6 meters. So, answer still in the calculator. We're going to hit subtraction, not this one, but in this case, we're going to subtract 6.38 second EE, get our exponent. Notice that little E shows up, to the 6 equals. And if done correctly, 9.85 times 10 to the 6 meters. So hopefully that helps. Things to look out for. Make sure your units are correct. Newtons, this needs to be in kilograms, and distance needs to be in meters. These are big numbers. Make sure you know how to input scientific notation. Okay, if you have any more problems, let me know. On the back, again, you have the answers, so you'll know if you're putting them in correctly. Okay, guys.